Welcome to the chapter 3 of our MCP journey. What are we diving into today? So we are exploring the architectural foundation that makes MCP the universal connector for AI applications. Why does architecture matter so much? Because understanding how MCP's client-server design works is the key to building robust, scalable AI systems. Ready to discover the elegant engineering behind the revolution? I hope you so. So, the MCP architecture is simplistic, the client-server architecture. That's what we're going to explore at this moment right now. So now as we deep dive into each and every component, the next question that strikes is, what is the philosophy behind MCP's design? It's built on a simple principle: don't reinvent the wheel, perfect it. So what's proven patterns does MCP follow? That's for the next question. It's inspired by Microsoft's language server protocol. In short, we call it as LSP, which solved a similar integration nightmare for code editors. How does it communicate? Through JSON-RPC 2.0, a battle-tested protocol that developers already know and trust. So why this approach? Because sometimes the most revolutionary ideas come from taking established patterns and applying them brilliantly to new problems. So the result is simplicity, scalability, and security working in perfect harmony. So now the next question that pops to my mind immediately is to what exactly is this client-server architecture everyone's talking about? Let me break it down clearly. On one side, you have the MCP client that you can see on screen here. This is your AI application host, or it is within the host is AI application host is hosting this particular client. That's one. And that contains, this AI application host contains the large language model like a Claude or GPT or Gemini or anything else. In the middle, let's go to the middle one. Here, there is an MCP protocol using JSON-RPC 2.0 for standardized communication. On the other side, you have MCP servers that you can see on here. So these MCP servers are specialized data and tool providers. But why is this particular separation? So you can see this particular analysis in detail in this diagram. You have the host. Within this host you have the clients, and then you have MCP servers, which are data and tool providers, and these two are speaking to each other through MCP protocol, which is nothing but your JSON-RPC 2.1. And that's your MCP architecture. It's not so complicated, but you need someone to explain it this way. I'm there. So let's deep dive into it a bit. So now you're just excited to understand what is host, what is client, what is server, right? And I'm here to explain that too. So hosts are LLM applications that want to access data through MCP. So example, it can be a Claude desktop, or it can be IDEs, integrated development environments, or AI agents. So these are the hosts. Our AI agent is an host. Now this host is gonna host the client. So now let's look into the client. So MCP clients maintain one-on-one connections with servers inside the host application. Again, I'm repeating, no confusion, with clear clarity. MCP clients maintain one-on-one connections with servers inside the host application. Clear? So now let's look into the third one, which is MCP server. So MCP servers are lightweight programs, a .py file if it is Python. If it is Java, it's a different file. If it is some other language, you can write on Kotlin also. But I'm talking from .py file. It's a lightweight programming that each expose a specific capabilities through MCP. So that's the MCP servers. Now, but why is this particular separation so important? It creates a clean boundaries. The client focuses entirely on AI intelligence and user experience. That ends. Then the servers handles data access and tool functionality, and the protocol ensures they can talk to each other seamlessly. So think of it like a well-organized restaurant. Just an example. So the chef focuses on cooking, the server handle customer interaction, and the kitchen pass ensures a smooth communication. So each component does what it does best, and the result is a superior experience for everyone. Let's hope so. You will have one with MCP. So that is about the client server architecture of MCP in detail. So now, what exactly does MCP client do? Of course, we have discussed some in previous slide, but however, let's deep dive in here. So think of it as the intelligent conductor of an orchestra. The client is an orchestra conductor. What are its key responsibilities? First, it hosts the large language model, whether that's the Claude, GPT, or Gemini, or anything else. Second, it manages connections to multiple MCP servers simultaneously. And you have the third one, which handles all user interactions and requests. And fourth, it orchestrates protocol communication between components. And finally, it maintains crucial security boundaries. So, why is this client so important? Because it's the command center that makes everything work together. Without a sophisticated client, you would just have an isolated components that can't collaborate. The client is what transforms individual servers into unified intelligent systems. That said, the next is to understand much more about the MCP server. Now, what about MCP server side? So each server is like a specialized gateway to a specific domain of functionality. What does a server actually do? First, it exposes specific capabilities through those standardized primitives we learned about. Second, it manages connections to external data sources, databases, APIs, file systems. Third, it handles authentication and authorization for its resources. Fourth, it processes requests and returns structured responses. And fifth, it maintains data security and access control. So that's the power of MCP server. Now, why this specialized approach? Because expertise matters. A database server knows how to optimize queries, handle interactions, transactions, and maintain data integrity. A file system server understands permissions, directory structures, and file operations. By having a specialized servers, each component can excel at what it is designed for. So now, let's look into the most important aspect of MCP, which is what are these three core primitives that make MCP work. They are called as the fundamental building blocks of MCP. Okay, so first, tools. So what are these tools? They are executable functions that AI can call to perform actions. Think API calls, database queries, or file operations. The AI says, I need to do something, and tool makes it happen. Second, you have the resources. What do these provide? So they are structured data that gives context to the AI model, documents, databases, configuration files, anything that helps the AI understand situation better. And the third one, what we have here is the prompts, or I call it as a prompt template. So how do these guide behavior? They are templated interactions that shape how AI responds. Database response. So workflow templates are system instructions or specialized reasoning patterns. So these are the fundamental building blocks of MCP. So why just 3 primitives? Why can't 10? So because simplicity is powerful. These 3 concepts can represent virtually any interaction between AI and external systems. It's like having 3 primary colors that can create any hue you need. Sounds crazy, right? So we have seen the building blocks of MCP, and now let's look into the flow between them. How do these components actually talk to each other? So the communication flow is elegantly simple. What happens in a typical interaction? Step 1. The client which is hosted by a host application, the client sends a JSON-RPC request to the server asking for something specific. Step 2. The server processes that request and accesses whatever resources are needed. Step 3. The server returns a structured JSON response with the requested data or confirmation. And step 4, the client integrates the data into the AI's context for decision making. But here, what makes it special, which is your bidirectional communication. Why is this bidirectional communication important? Because both clients and servers can initiate requests. This enables rich interactive experience where servers can proactively update clients and clients can orchestrate complex workflows across multiple servers. So that's the reason bidirectional communication is a game changer for MCP. So now let's move into the most important aspect of the MCP, is how does MCP handle all the crucial aspects of transport and security. So this is where the protocol's flexibility really shines. What transport options are available? MCP is transport agnostic completely. It works over STDIO for local processes, HTTP for web services, or WebSockets for real-time communication. And the next question is, how does the security actually work? So multiple layers, authentication supports various mechanisms depending on your needs. Isolation creates a clear boundaries between client and server components. And here is a key point: no API keys are required in the traditional sense because servers are control their own resources directly. Crazy, right? So why is this security model so effective? Because it follows the principles of least privilege. Each server only exposes what it chooses to expose, and clients can only access what servers explicitly allow. So security isn't an afterthought, it's built into the protocol from the ground up. So then comes the most important aspect. The important question from each and every enterprise is, how does MCP handle enterprise scale deployments? You would worry if I say the results of MCP scaling. So Google is using, Microsoft is using, OpenAI is also using, GPT is also using. Just that tells the answer. But however, let me go through it. So the architecture is designed for massive scalability from day one. What makes it so scalable? First, there is no theoretical limit to servers per client. You can connect thousands if needed. Second, the protocol is stateless, which means it can handle enormous loads without memory overhead. Third, high performance is built in through efficient JSON-RPC communication. Why does this matter for enterprises? Because you can start as small and grow infinitely, whether you are connecting to 3 databases or 300 databases or 3000 databases. So the architecture scales seamlessly without performance degradation. It's awesome, right? Just try it out. So then comes the next question: where is the architecture being used right now in a real world? It's already powering production systems across the industry. How is Claude desktop using it? Through local MCP servers for secure file systems access. What about enterprise tools? They are connecting to internal databases and APIs without exposing sensitive credentials. And how are development IDEs leveraging it? For a real-time code context and version control integration. And what about the web applications? They are enabling dynamic content management and live editing capabilities. The beautiful thing, this isn't a theoretical, it's a battle tested in real production environment. What are you waiting for? Just grab a cup of coffee and your laptop and start building an MCP server. I'm here to guide you. So then comes our why this architecture is winning. So why has this particular architecture become the industry standard? 4 key reasons make it unstoppable. First, reusability. This we have already discussed. And then second one is the security. And the third one is the scalability. And then the fourth one is the flexibility. The combination of benefits is why a major companies adopted MCP so quickly. So it solves real world problems elegantly. And what's next? That's what the question. So where do we go from here? So chapter 4 is where theory meets practice. What will we see? So live demonstrations of MCP in action. So to make it simple for you, even without writing a single piece of code, I will make you to build and use the MCP servers so that you can understand much better. So first you need to understand the entire architecture. You should be able to visualize and intuitively see everything. So that's the reason my first demonstrations are in a simplistic way without writing a single piece of code. Okay, just get ready for it. Just grab a cup of coffee and watch the video. So then watching the servers and client communicate in real time and experiencing the power of universal AI connectivity in first hand, you now understand the elegant foundation that makes MCP work. Next, we will see it come alive, ready to watch magic happen. See you there.